In Chapter 4, Part 7, we are going to look at absolute value, and we're just going to start with number 99 with graphing. So we are given the absolute value function. Remember, anything in absolute value is going to be a positive number, 0. It's the distance from any number to 0 on the number line. So if we start by plugging in some of our x values, absolute value of -5 is going to be 5. Absolute value of -4, that's 4 spaces away from 0. -3 is going to be positive 3. -2 is 2. Absolute value of -1 is 1. 0 is 0. Absolute value of 1. 1 is 1 space away from 0. And then you can kind of see that there's a pattern going on here. So this is called absolute value. And we are going to graph the points next. Once the points are graphed, you will see that the absolute value has a V shape, and it's going to be going forever for our domain, going from left to right. And we can look at our x-intercept. So we can find the x-intercept two places. We could find it looking at the graph or looking at our table. Same thing with the y-intercept, and the x and y-intercept for this problem are going to be exactly the same, 0, 0. So we are looking for a special point called the vertex, which is going to be the very lowest or the highest point of our absolute value function. And in this case, it's also going to be 0, 0. So it is the very lowest point of our graph. And then we want to answer, is it a function? So if we do the vertical line test, if we draw a vertical line anywhere through the graph, it is going to pass one time, so it is a function. The last part of this problem is to find the domain and the range. So we are going to look at it in three different ways. So in the words part, if we look at our domain going from left to right, so I'm going to go back to my graph. Remember, we're looking at the very first x value and the very last x value. So if we look, we got two arrows. So this domain is going to be from -infinity to +infinity. So no matter what, any x value is going to work. So when we go to write it as an inequality, we'll have -infinity is less than x, which is less than infinity. And then our interval is going to be in parentheses. Remember, infinities never get brackets. So our domain could be any real number. It could be anything. For our range, we're going to go from the bottom of the graph to the top. So we're looking at the very first y value, which is 0. And then the very top of the graph, it's going forever. We have those arrows. So our range is going to be from 0 to infinity. So 0 is an included point, so it's going to be 0 is less than or equal to y, which is less than infinity. And then our interval, since 0 is an included point, it's going to be in a bracket. So 0 is an actual point on the graph. So our range could be anything from 0 to infinity. So absolute value notes. Absolute value represents the distance a number is from 0 on a number line. Since absolute value is a distance, the result of finding an absolute value is 0 or a positive number. It is very important to note that all distances are positive. So we were never traveling negative miles or going, a negative distance. It's always positive. In example 1, we are going to solve the absolute value of 2x plus 3 equals 7. So first you want to make sure the absolute value is isolated, that it's by itself, and if you notice, it is. There's nothing being multiplied, added, subtracted, divided, along with the absolute value. So once it is isolated, we are going to create two equations. So the first equation is going to look identical, except you are removing the absolute value bars. This is equation number 1. Equation number 2 is going to be the 2x plus 3 equals -7. So notice that you are changing the sign here of that 7. Everything else stays identical. So at this point, we are going to take each equation and we're going to solve like normal with equations. So I'm going to subtract 3 on both sides. 2x is equal to 4, and then divide both sides by 2. So x is going to equal 2. That is one of our answers. Take the other equation, 2x plus 3 equals -7. Subtract 3. 2x is now equal to -10. and then divide by 2. So x is also going to be equal to negative 5. So the final step is just to check to make sure we did it okay. So if we go back to the original absolute value and you plug in 2, so we'll say absolute value of 2 times 2 plus 3. So 2 times 2 is 4, 4 plus 3. So the absolute value of 7 is going to be 7, so that works out because it's equal to 7. And then we're going to plug in negative 5. So take 2 times negative 5 plus 3, an absolute value, which is negative 10 plus 3, which will give us negative 7 in absolute value, which is also equal to 7. So both of them do work out. So 2 and negative 5 are both answers for x. So in example 2, we want to get that absolute value by itself, but you will see that it's being multiplied by 2. So we need to divide both sides by 2. And what happens is when we take 2 times absolute value, do not distribute that. You can't distribute with absolute value. Instead, we're just going to eliminate those 2's, and we're left with the absolute value of 2x plus 13 is now equal to 5. That absolute value part is by itself, and now we can break it into the two equations. So we'll have 2x plus 13 is equal to 5, and 2x plus 13 is equal to negative 5. So we're going to solve, so we have 2x plus 13 equals 5, so we're going to subtract 13 on both sides. So 2x is equal to negative 8, divide by 2. So one of our answers is going to be negative 4, which we'll check in a second. The other equation, 2x plus 13 is equal to negative 5. Subtract 13 on both sides. 2x is equal to negative 18. Divide both sides by 2. X is going to equal negative 9. So to check our work, you could plug it into the original absolute value equation, or you could plug it into the one that you kind of rearranged, got the absolute value by itself. So if we plug in negative 4 in for x, I'm just going to do my check up here. We're going to take the absolute value of negative 8 plus 13, which is absolute value of 5, which equals 5. So that works out. If we plug in negative 9 in for x, that would be the absolute value of negative 18 plus 13, which is equal to the absolute value of negative 5, which equals 5. So that also works out. The final problem we're going to look at is 101. So we're going to do the absolute value of x plus 2 equals 4. This absolute value equation is already isolated, so we're going to set it up as our x plus 2 equals 4. So it stays identical except the absolute value bars are removed. And then x plus 2 is now equal to negative 4. So we are going to solve each one algebraically. So we'll subtract 2 to get x is equal to 2. And then we will subtract 2 on both sides over here to get x is equal to negative 6. And then we can check to make sure that it works out. If we plug 2 back in, absolute value of 2 plus 2 is absolute value of 4, which is 4. If we plug in negative 6, absolute value of negative 6 plus 2 is equal to absolute value of negative 4, which is 4.